Hi everyone, so today we are going to be looking at the halogenation of an alkane. And all this means is taking a halogen, so something like bromine, fluorine, chlorine, blah, 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 blah. Hi everyone, so today we are going to be looking at the halogenation of an alkane. And all that means is taking a halogen, so something like chlorine, fluorine, bromine or iodine, and adding that to an alkane. So methane, ethane, propane, etc. Today specifically we'll be looking at the addition of chlorine to methane. So halogenation of an alkane is quite an important reaction because it's one of the few reactions that an alkane will actually undergo. And it's beneficial because alkanes themselves don't react that much, so by adding a halogen to them it increases their reactivity and makes them more useful to us in a synthetic sense. So we will break it down today, okay? So it takes part in 3 different steps. So that will be initiation, propagation and termination. You will come across possibly a few new things today, so we are going to be using our curly arrows. And if I just do this in the top right hand corner here, we are going to be looking at a half or one-sided curly arrow, which indicates the movement of one electron. And we will also be looking at the movement, God damn it, motherfucker. Hi everyone, so today we are looking at the halogenation of an alkane. And all that means is taking a halogen, so something like bromine, fluorine, chlorine or iodine, and adding it to an alkane. So something like methane, ethane, propane, etc. Today specifically we will be looking at the addition of chlorine to methane. Now, a halogenation of an alkane reaction is quite important because alkanes don't really undergo many reactions themselves. So by adding that halogen to them, we increase their reactivity and we increase their usefulness because they can partake in different reactions later on. And obviously that's important synthetically, okay, it makes them more useful to us. The reaction itself takes part in 3 ways. So we have initiation, propagation and termination. We'll walk through each of those now in a moment. The main things that you will come across today, okay, when we're getting familiar with our reactions, we are looking at the presence of electrons in the outer orbital of our atoms, and basically they're the ones that are going to be partaking in the reactions, and we'll be looking at the movement of those electrons through the use of curly arrows. So just before we go on, halogenation of an alkane, that involves the generation of something called a free radical. And a free radical is something that will have one lone electron, okay? And it's usually just indicated by a simple little dot like this. Now, when we want to talk about the movement of those electrons, we use a curly arrow with a half head. And that will look something like that, okay? If we were talking about the movement of 2 electrons, okay, so we had 2 electrons, we would show a curly arrow with a full head here. So for today with halogenation, we are only interested in the movement of 1 electron because we'll be dealing with radicals, okay? So just keep that in mind as we move throughout. So we can get started, okay? So we're looking at the initiation phase. And this involves a chlorine molecule, and we want to split that chlorine molecule into 2 chlorine radicals. Okay? Now, if you left it as this, so I'll just highlight it here. If you just showed me that, it's not enough, okay? It doesn't give me enough detail. I don't know where the electrons are. I don't know which way they're moving. I don't know what bonds are being broken and what bonds are being formed, if any. I don't know any of the conditions that are set, okay? So you need to tell me that if you're presenting this to someone. you need to make sure they know it. If you're writing an exam, you need to make sure they know it. It's essential information. Okay, so the first thing I'm going to do is I'm going to identify the electrons that are present here, okay? So for chlorine, chlorine has 7 electrons in its outermost shell. And I'm going to just show those in blue. Okay, and there's one here on each side of this bond from each chlorine. Okay, so then you can count them that they have 7 of their own, plus 1 shared from that bond here. So this chlorine gets 8 in total. And the same goes for this guy when we count them, because this one is also shared. So they both have 8, they're happy. Okay, this chlorine molecule is quite happy. Now, when we split them up, okay, you get chlorine no, sorry about that. You get a chlorine with 7 and a chlorine with 7. Okay, now because chlorine has 1 lone electron, okay, if you can identify it, so we'll show it here. This is our lone electron, and the same here. These become known as chlorine radicals. Okay, and they're highly reactive, okay? They want to react. They want to find something that they can bond with to complete their octet and make them happy. Okay, so these are going to be highly reactive and they will be carried down to our propagation phase. Now, this still isn't enough, okay, because it hasn't shown me the movement of those electrons. Okay, so if we go back to our left side of our reaction, I want to show the movement of these two electrons that are involved here. So I'm going to say 1 electron has moved this way, 1 has moved this way, indicating the bond is broken, and that shows me what has actually happened, okay? I also need to show the condition, okay? So this breaking of this bond doesn't happen by itself, okay? It needs an energy input, and the energy input is coming from UV light. Okay? So it's only then that we have all the information we need. So we can see that we had a bond here. We can see that we broke this bond here with the movement of electrons. We can see that we required UV light. We can see that we broke the chlorine up into 2 individual radicals. And we can see that we have a lone electron in each radical. Okay, so loads of information there. And next then we move on to propagation. And propagation involves taking one of these chlorine radicals, so Cl, and taking what we're actually working on. So we're working on an alkane, and today it's methane. Okay. Again, a chlorine, we are clearly indicating the presence of a free radical there. Now, if you like as well, you can identify, because obviously electrons are what's actually involved in these bonds, so you can highlight them here. Okay, between all of those covalent bonds, there's electrons on either side being shared by the carbon and the hydrogens, okay, and they are what's going to partake in these reactions. So, again, showing our curly arrows, we know this free radical, or this lone electron here on our chlorine free radical is going to interact with something. And the easiest thing for it to react with is going to be hydrogen. So by showing our half-headed curly arrows moving together, we are showing that a bond is being formed. Now, hydrogen itself, I'll just highlight here, so hydrogen itself will only ever share 1 bond, okay? And again, this goes back to it having no more than 2 in its outer shell. If you don't know why it only has 2, go back and look at your periodic table. So, in order for it to form a bond with chlorine, it has to break one with, it has to break a bond with the carbon. So this is showing us that it's breaking. Now, when a bond forms between chlorine and hydrogen, you get HCl. And again, we are going to indicate on the chlorine all of our electrons. And we know there's one now being shared with a yellow one from hydrogen. What we also end up with is something called a methyl free radical. And again, you can indicate the presence of free radical here with basically just a large dot in bold essentially, okay? And this is known as our methyl free radical, or methyl radical. Okay. Now, okay, so our propagation phase actually has 2 steps. So we're going to remove termination here for the moment. Just make life easier for us. So what's going to happen now is our methyl free radical is going to be reacted with something, okay? So bring down our methyl radical. Again, indicate the presence of a lone electron. And this time, it's going to be reacted with our chlorine molecule. Now, you have to remember, if we think of this in a lab setting, okay, this isn't just a load of chlorine radicals, methyl radicals, etc. neatly stacked, okay? These things are all mixed up and, you know, things don't necessarily happen in a neat way. So you will have many species existing at once. So you will have chlorine radicals, but you'll also have chlorine molecules here. Okay? And in order for this chlorine molecule to react, we know it has to be split up, okay? We know it has to break. So again, we are going to identify its electrons, okay, the 2 that are involved in the bond. And we're going to show, one, that this electron, I'll highlight it here. So let's say this electron here, that's going to move towards this chlorine, and this one here, that's going to be involved in a new bond, okay? So that's going to move over here, and it's going to interact and bond with the lone electron from the methyl radical. So when we do that, we get a chlorine radical by itself, and we get our product. So when we add a methyl radical together with chlorine, we get chloromethane. So again, showing our electrons here is largely important. We know we have 1 electron there, and we know we have 1 here. Okay? Now, when you're doing this again, highlight. So name your product. So this is chloromethane. Okay, so we're nearly done. Our final step, we said, is termination. So we're ending the reaction. And now, you may think that's already ended. We've gotten our product, so what else do we have to do? Well, if you look, and again, there's many of these floating around, isn't there? So we have chlorine, or chlorine radicals. We have chlorine radicals floating around. We have methyl radicals floating around. Okay? And because of that, okay, and because they are highly reactive species, we need to make sure, or we actually don't need to make sure, they will react. Okay? And they will react no matter what. And we just need to summarize that. We need to show that. And we need to show that we know that's happening too. Okay? So the easiest thing to start with is our chlorine radicals. Our chlorine radicals can react with each other. Oops. Our chlorine radicals no, sorry about that. Now, our chlorine free radicals can react with each other to form Cl2, or just make it easier for ourselves again, so showing the bonds between. Again, I am showing the electrons. I am identifying the lone electron there that's going to take part in that bond. Okay, and I'm going to do the same over here while I'm at it. showing that those electrons are now being involved in that covalent bond. And I'm showing the movement of those electrons. So I know this lone electron here is going to move here, and indicated by my single-headed arrow, my half arrow. They're going to move together and form a Cl-Cl bond. So that's one way it can happen. The other way it can happen is our chlorine radical plus our methyl radical. And that can give us, again, a product, okay, so chloromethane. So carbon with 4 bonds. One of those bonds is now a chlorine. And again, go back. And you might find this a bit tedious, but it is important to clearly identify them. And showing the electrons on our methyl free radical too. Okay, and showing it over here as well. So we can have a chlorine reaction with a chlorine radical reacting with a methyl radical, and then finally we can have two methyl radicals react together. So if we have carbon with our 3 hydrogens, and carbon with our 3 hydrogens, we can form ethane, And again, so this time we are just showing these guys here and there, just so for your own clarification. Okay, that's where that bond has been formed. So again, we are showing this electron moving here and this electron moving here to form that bond between 2 carbons to give us ethane. And again, you're going to be extra great and you're going to name them, okay? So you are going to write out the name of the product. Ethane. You're going to say this one is chloromethane. And you can say this one is chlorine. Okay? So then, that's it. That's everything done. Okay? And what we end up with is a step-by-step mechanism of the halogenation of alkanes. The best way to do these is with practice. It means watching this video a couple of times, pausing it, writing it down for yourself and explaining it out loud to yourself or to a friend what is actually happening. Why is that electron there? Why is it moving that way? What bonds are forming and what bonds are breaking. Okay? Give it a go, and if you do have any questions, pop them in the forum on the Moodle page.